Elimination reactions are kind of like the opposite to addition reactions. Is in this reaction type we are forming a double bond between two carbons. In the two reactions or two ways we have elimination reactions in year 12 is through the removal of an alcohol or a halogen and a hydrogen from two neighboring carbon atoms, and thus forming a carbon-to-carbon double bond. For example, here we are removing the OH and H, or H and Br, to form the double bond between those two carbons. So, elimination in alcohols. The reagent that we need to do this type of reaction is concentrated sulfuric acid. And in that reaction, we remove the OH and the H, forming a carbon-to-carbon double bond, and also water is the byproduct. So any sort of elimination reaction between an alcohol to an alkene involves the use of concentrated sulfuric acid. Haloalkanes have a different reagent. This reagent is potassium hydroxide in alcohol. That's what AlC means down here. Now, this is different to the last time you saw potassium hydroxide, which was aqueous, because potassium hydroxide in aqueous solution actually does a substitution reaction. So it's very important to make sure we get this right, that in an elimination that the KOH is an alcohol. And in this reaction, again, it's the same sort of thing with a halogen, the same chlorine, and a hydrogen from the neighboring carbon. These leave, forming a carbon-to-carbon double bond. And the HCl would be lost as a byproduct. So those are the two types of elimination reactions. Now, if we have a situation where the haloalkane or alcohol is not symmetrical, you're going to form two products. And for this, we're going to use the reverse of Markovnikov's rule to predict which is major and which is minor. So rather than the rich get richer, we're going to focus on the poor get poorer. So focusing on this carbon here, because this carbon has the alcohol group, the OH, and we've got to look at the two carbons next to it, so that one there and that one there. The one that is poorest is this carbon here. So that is going to lose the hydrogen in the major product. So if we write that now, the major product will have the double bond between carbons 2 and 3. And you'll form butene through that reaction. So that's the major. If, on the other hand, we remove the hydrogen from this carbon here, where there's more, so that's the richer one, that only occurs when we make the minor product. So that will make butene. Like so. So that's the minor. So that's something to bear in mind. There's a potential for two products to be formed in elimination reactions, whether it's an alcohol or a haloalkane.